Okay, hi everyone, welcome back to this video series on Introductions to Firewalls, Chapter 14, Configuring Linux as a Firewall. As Linux gains increasing acceptance in corporate data centers and other places, more and more people are discovering something that Linux enthusiasts have known for a long time. Linux has built-in firewall features that allow an administrator to build a firewall. Recent versions of Linux generally ship with at least basic firewall capabilities, and several Linux versions include even more advanced features. Because Linux is open source software and because it has only minimum hardware requirements, you can build a Linux-based firewall relatively inexpensively. Be forewarned though, doing so requires some knowledge of Linux and how it fits into the networking scheme of things. Making installation choices. To use the firewall built into Linux, you should make sure that the operating system you install includes iptables functionality. iptables is the most popular Linux firewall, and this covers it in detail. Fortunately, most Linux distributions do this by default, so you probably don't have to worry about this. Before you install Linux, make sure that all your network cards and any modem that you may use are installed in your computer. Generally, it's much easier to have all your hardware in place before installing your Linux software than it is to install Linux first and then try and get Linux to recognize all the hardware stuff after the fact. Red Hat Linux, in its ongoing effort to be top dog in the Linux field, goes one step further along the customer satisfaction road by giving you a choice of configuring the firewall during installation. One of the screens that you see during the installation procedure is shown in figure 14.1. The choice you see on this screen are good starting points, whether you are just setting up a personal computer or whether you are planning to configure a corporate firewall. Of course, you are indeed configuring a dedicated firewall. You will have to perform some additional configuration after the initial installation is complete. If you are using another distribution, just skip this section and go on to the section iptables. The process of configuring the firewall after installation is virtually identical in all Linux distributions. Let's look at each of the individual choices off. This option does just what its name implies. It configures Linux to allow all network traffic to enter or leave the computer. Obviously, this is not an appropriate setting for a firewall unless you want to do all your configuring at the same time. Medium, this is an appropriate choice if you want to use Linux as a personal firewall or if you are installing a server that performs limited functions, such as a web server. When you select this option, Linux configures iptables to allow certain types of traffic into your computer. You can specify which type of traffic are allowed. For example, you can disable HTTP traffic or allow SMTP traffic. One of the limitations of the Red Hat setup program is that it can only perform very simple firewall configuration tasks for you. Keep in mind that you can add or remove rules later, but if you already know which traffic you want to allow and which traffic you want to block, you can easily configure this during setup. Hi. When you select this option, you enable and configure the iptables firewall to block all traffic. This is the configuration you should choose when you install a dedicated firewall. Best practices dictate that you configure your firewall to drop all network traffic unless you specifically allow it. Choosing this option gives you this starting configuration. You get to do all of the other configuration steps after the operating system installation is complete. Introducing IP tables. Although we've already mentioned IP tables a few times in this chapter, this is the section where we actually get down to brass tacks about the whole IP tables business. IP tables is the command that you use to tell the Linux kernel, the core part of the operating system, how to treat network traffic. For example, you can use the IP tables command to drop IP packets, forward them, or perform network address translation (NAT). Before you can configure rules with the IP tables command, you'll have to understand a few concepts and Linux specific terms. Tables. Locations where a firewall stores and maintains a set of rules. The main table is the filter table, where you define most rules that apply to incoming and outgoing traffic. This is also the default table that commands apply to when you don't specify a specific table. The NAT table contains rules that define how Linux performs NAT. The managed table is used for advanced packet routing, but isn't used frequently. Chains. At the core of the Linux firewall, using a chain to lock your computer to a desk may be a good idea, but in this case you're talking about a different kind of chain. Linux uses this term to refer to the set of rules that Linux applies when filtering network traffic. Here are the three main chains, each of which is part of the filter table. Input chain. This chain applies to all traffic destined for the firewall computer. For example, if you want to enable remote administration on your firewall, you have to configure a rule for the input chain to allow whatever network traffic your remote administration tools use. Output chain. The output chain applies to all network traffic that leaves the firewall computer. For example, if your firewall needs to contact a DNAT server for name lookups, you have to configure the output chain to allow this traffic. Forward chain. This chain applies to all traffic that your Linux firewall handles for other computers. For example, if your firewall allows network traffic from client computers to the internet, you have to configure the forward chain to allow this traffic. SNAT, DNAT, and masquerading. These terms refer to the different forms of network address translation. SNAT changes a packet's source address before sending it on. This is most often used to hide the real IP address of a client computer in outgoing traffic. DNAT changes the destination address of packets, which is commonly used for transparent proxies, proxy servers that handle network traffic for clients without the client knowing. Masquerading is a specialized form of NAT because it doesn't require a static IP address. Masquerading also hides internal clients from the outside world and is used when your external IP address changes dynamically. For example, when you use a dial-up connection to connect to the internet, just like dressing up in a costume changes someone's appearance, masquerading changes a packet's appearance to the outside world. Using IP tables commands. Linux includes a number of different IP tables commands. All of them start with IP tables and adds a number of command line options. The best way to start using the IP tables commands is to look at the basic syntax for firewall rules. To instruct Linux to add a rule to one of the chains or to remove one of its rules, the syntax is as follows. Optional parameters are shown in square brackets. IP tables commands must specify the table where the command will be applied. The command itself, the chain to which the command will belong, an expression that defines what type of traffic that filter will apply to and what Linux should do with the packet. For example, to add a simple rule to the input chain of the filter table that would drop all ICMP traffic, your code would look something like this. IP tables minus T, filter minus A, input minus P, ICMP drop. As you can see, this command starts with the required IP tables. It then specifies which table and chain it refers to, goes on to include a match expression, and then finally defines a target. This particular command tells Linux when the filters table input chain receives a packet that uses the ICMP protocol, send the packet to the drop target. In other words, dump all ICMP traffic. IP table commands. Before you can build your own IP rules, you have to familiarize yourself with the basic commands: filter, match expressions, and targets. Table 14.1 describes the most commonly used IP table commands. So minus A, append. This command appends a rule to the end of the chain. Minus I, insert. This command inserts a rule to the beginning of a chain. Minus D, delete rule. This command deletes a rule. Minus L, list. This command lists all rules in a chain. If you don't specify a chain, the command lists the rules in all chains. Minus N, new. This command creates a new user-defined chain. You can create new chains with separate processing rules that can process packets before they're returned to normal processing. Minus X, delete chain. This command deletes a user-defined chain. Minus F, flush. This command deletes all rules in a chain. If you don't specify a chain, the command rule deletes all rules in a chain. Minus H, help. This command lists all IP tables, commands, and options. If you add minus H to another command, IP tables lists all available options for that command. IP tables targets. Before using IP table commands, you must understand the concept of a target. A target is the destination where the chain will send a packet, but you can also think of a target as an action that Linux will perform with the packet. Table 14.2 lists the most common targets. So drop. When a rule sends a packet to a drop target, it is instantly discarded and never heard from again. Don't feel bad for your packet though. If you don't want it to get through your firewall in the first place, then you don't need to get all teary-eyed for getting rid of it. Reject. When a rule sends a packet to the reject target, it is discarded. However, instead of doing so silently, Linux sends an ICMP packet to the source informing it that the packet was dropped. Although this is a polite response to dropping a packet, in most cases it isn't recommended because it can give an attacker an indication that something is responding at the other end. Most of the time, the safer choice is the drop target, except use rules to specify this target for packets that you want to pass through your firewall. Choosing this target means that the packet is accepted and sent on its merry way, either into your network or out of your network, depending on its destination. Log. This target simply means that the packet is logged. No further action is taken. A common place for the log target is a user-defined chain to which you send packets to be logged and dropped, while the regular chain keeps processing other packets. SNAT. This target can only be used in the posturing chain of the NAT table. Using SNAT changes the source address of a packet to an address that you specify. Keep in mind that you use this option with firewalls that have a static IP address. SNAT is normally used with outgoing packets. DNAT. This target can only be used in the protruding chain of the NAT table. Using DNAT changes the destination address of a packet to an address that you specify. DNAT is normally used with incoming packets. User chain. The italics here mean that you have to replace the words user chain with the name you gave your user-defined chain. You can choose whatever name you want. You can send a packet to such a chain for further processing. For example, a user-defined chain can perform further processing, such as logging packets that match certain conditions and then dropping them without interrupting the order of processing for other packets. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.